Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine you're conducting an orchestra, but instead of violins and cellos, you're coordinating GPT-5, Mixtral, QN, search tools, and code interpreters. Now, here's the twist. What if your conductor keeps pointing to the loudest, most expensive instrument every single time? This is the story of SkillOrchestra, learning to route agents via skill transfer by Jiayu Wang and Yifei Ming. And it tackles one big question: how do we orchestrate AI agents intelligently without wasting cost or collapsing to one giant model? Modern AI systems are compound agents. They search, they code, they reason in multiple steps. Traditional routing does something simple. It picks one model for the whole query, but multi-turn tasks don't work that way. Then came RL-based orchestrators, more flexible, yes, but expensive to train. And worse, they suffer from something called routing collapse. In the paper's experiments, router R1 selects Llama 70B for 98% of calls. That's not orchestration, that's obsession. So, what's the core idea? Instead of learning a routing policy end to end, SkillOrchestra learns a skill handbook, 3 layers. First, mode level insights. When should we search? When should we code? Second, fine grained skills, not just coding, but symbolic logic, data processing, numerical reasoning. Third, agent profiles. For each model, we estimate skill specific competence and cost. So, at runtime, the orchestrator does two things: what should be done, who should do it, and it optimizes this explicitly: expected skill competence minus cost. Here's where it gets interesting. They don't stop at discovering skills, they refine them. If a skill is too broad, split it. If two skills behave identically across agents, merge them. Then comes Pareto optimal handbook selection. Why? Because not every orchestrator can handle fine grained distinctions. A weaker backbone might misclassify symbolic logic as numerical approximation, and suddenly it routes to the wrong agent. So they validate subsets of the handbook and select the one that maximizes reward minus cost. Now the results. Across 10 benchmarks, SkillOrchestra outperforms RL-based router R1 by up to 22.5 percentage points. And here's the wild part: 700x lower learning cost compared to router 1, 300x lower than Toolorchestra. Even in full agent orchestration with search and code modes, it beats proprietary systems like GPT-5 orchestration setups in performance cost trade-offs. And importantly, the skill handbook transfers. Learn it once with Quen 3B, apply it to stronger orchestrators, no retraining required. So what's the deeper message? SkillOrchestra reframes orchestration, not as policy optimization, but as structured knowledge acquisition. Instead of training a smarter conductor every time, you write a better score. The system becomes interpretable, balanced, transferable, and most importantly, scalable. As model pools grow, this skill centric abstraction may be the difference between chaos and symphony, and that's SkillOrchestra, a framework that doesn't just route agents, it teaches them how to play together. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.